First, I have prepared these 4 types of walls, and I'm going to use them to construct a simple exterior wall of a building. Open the newly created blueprint and PCG graph. There is a spline component in the blueprint. Let's add a PCG component and put it into the newly created PCG graph. Then we go into the PCG graph and start to write our syntax nodes. First, obtain the spline data with the target being itself. Then pull out a branch node. This branch is just my personal habit, which is convenient for hiding the model. Everyone can just ignore it. Then add a height attribute along the upward axis to the spline. Here, set the output target as extrusion, and then connect the height variable. I forgot to add the vector attribute. Since we need to set the floor height here, we need to connect the z-axis. Then add a syntax attribute. The syntax here is used to control different floors. Here, you need to connect the variable of the syntax. For the third node, we connect it to a duplicate cross-section node. The function of this node is to duplicate the same spline above the original spline along the spline path. In the duplicate cross-section node, you need to check the extrusion vector as an attribute, and then write the previously added extrusion attribute here. In order to write our module information using the blueprint, check the module information that serves as the input. Finally, add the syntax attribute to it. Here, let's write the variable as module information underscore z. These 3 nodes can be used to generate the model of each floor. Next, we need to create a model that is generated along the x-axis of the spline. The first node is the spline direction node. This node determines whether the model should be generated counterclockwise or clockwise. Here, we'll set it to generate the model in a clockwise direction. The second one is the spline 2 segment node. The third one is the select syntax node. This node is used to control the conditions for generating the model along the spline. Change the key attribute here to the name of the symbol attribute in the duplicate cross-section node. In order to write the rules using variables, check the option for the standard that serves as the input. Then connect the variable. I need to sort these out quickly first, otherwise it will be uncomfortable to look at. Drag in a subsegment node and make it segment along the x-axis direction of the spline. Check the syntax attribute here. To write the module information using the blueprint, check the module information that serves as the input. Then, connect the variables of the second module information and the model. Change the names of these two variables here. Drag in a match and set attribute node, and replace the input attribute and the matching attribute with the key attribute in the select syntax node. Then connect the module information to the model. Finally, connect the static mesh generator, change the mesh selector to select mesh by attribute, and set the attribute name to mesh. Okay, this simple row of nodes is the core of the first syntax. Next, we need to create all these variables in the blueprint. The first variable is for generating the model, and its type is Boolean. Then, create a variable named height of the floating point type. Next, create another variable for the syntax. Its data type should be a string. Then, create a variable for the module information. Then create a variable named module information with the data type of PCG subdivision, submodule. Change the data type of the module information variable to an array. Then create another variable for the module information along the x-axis of the spline. Create a variable for the selection syntax with the type PCG select, grammar criterion. Finally, create a module variable. with the data type of static mesh. After completing all the operations, compile the project, save the changes, and then go ahead to test it. Drag the blueprint into the relevant area. Set its height to 400. In the syntax, first write the first layer and input the name layer 1. After that, set up the module information for the floors. For the first floor, set the name as L1 and the height as 400. Then, set the module information and the model along the x-axis. Name them as WQ1 in order and set the width to 50. Then, continue to set another item named WQ2 and also set its width to 50. Next, use the same method to set the following two items. You can name them according to your preference, but make sure the width is consistent with the width of the model. Then, add the models. You need to add them in accordance with the sequence of the above-mentioned module information. Finally, you can write our rules in the selection syntax. In the first line, set the key as the name of your floor, which is L1. When the length of the spline segment is greater than 100, first make it generate an infinite number of external wall 1 models. When I press the Enter key, it generates walls with a width of 50 along the spline line. I set the length of the spline line to 1000, so it generates 20 wall models. Next, I will first drag the spline line to form a simple square-shaped wall, and set both the length and the width to 2000. Make it a closed loop, and then set all the spline points to be linear. Write a more detailed model generation sequence for it. This syntax on the screen generates models in the order from left to right. It means that the first model is external wall 2. The subsequent asterisk symbol represents that it needs to fill models within a limited distance. In the middle is curtain wall 1 plus 4, and it is required to generate 4 of them. Finally, the logic is the same as that of the first one. In this way, all the wall surfaces are handled in the same manner. However, we need to make the rules a bit more complicated. The meaning of this rule is that the generation will only occur when the distance of the spline segment is equal to 2000. I'll add another spline point to this side and change the distance to 2 segments of 1000 each. Therefore, we need to write a rule for the distance of 1000 as well. When the distance is equal to 1000, create the model according to the syntax entered below. Following the above logic, many complex shapes can be generated. Due to time constraints, I'll only demonstrate a simple square-shaped wall here. I'm going to change the floor height to 3 stories. Then, I'll write the rules for the second floor. All the syntax should be separated by commas. The height of the second floor is also set to 400, because the only models I've prepared are 400 in height. Other heights can be set as required. For the selection syntax, you can write the rules in the same way as before. There are various ways to write the syntax, and you can check the official website for details on your own. From here on, it's all repetitive operations, so I need to speed up. Next, I'm going to make several copies of the blueprint and use the same method to generate walls of other styles. With this blueprint, not only can you create floors, but also a great variety of other things, such as guardrails, roads, and so on. Okay, the tutorial for the first type of syntax is over. If there are still friends who haven't gone to bed, you can give me a follow. See you next time.